Solving example 5, which was the last example of video 5, we have to use the corollary to the triangle proportionality theorem, which was this guy right here. So looking at this particular problem, these two pieces are going to go together as a ratio, and these two pieces are going to go together as a ratio, and we can set them equal to each other. Now, two different ways to look at this problem. We're going to start off looking at it just the way it is. If I were to go ahead and cross multiply this, when I distribute the 4x to the 6x minus 10, I'm going to end up with 24x squared minus 40x. And when I cross multiply with the 5x, I'm going to get 20x squared plus 40x. Now, I need to move everything over to the same side. Okay? So I'm going to subtract the 20x squared over. Subtract it over. And I'm going to go ahead and subtract the 40x over as well. So that on one side I have 0. Now over here I've got 4x squared minus 80x. Now you might be thinking, oh crap, this is going to be a factoring problem or a quadratic formula problem. But notice there's one little thing missing, and it's the constant, right? Just our regular old plain old number with no variable attached. This is a good sign. Okay? We're not going to factor it because it's not a trinomial. We have a binomial here. So what we're going to look for is, what do these two things have in common with each other? Well, they both have a factor of 4 in common, and they both have an x, right? So what's left over? Well, if I factor out a 4x from 4x squared, I get just x. And if I factor out a 4x from a minus 80x, I'm going to get a minus 20 equals 0. Now at this point, this kind of looks like what we would get after we factor something, right? If we factored a trinomial. What I can do now at this point is take these two things and set them equal to 0. So 4x equals 0 and x minus 20 equals 0. And I get x equals 0 or x equals 20. Which one's the good answer that's really going to work both algebraically and geometrically? X equals 20. Because if I plug 0 in, this piece is 0, this piece is 0, this piece is 8, and this piece is negative 10. That definitely does not work 3 out of those 4 ways. So 20 is my only real answer here. Now I'm going to backtrack, and I'm going to show you how you could have made this problem much more simple. If you had tried to simplify things first, things would have worked out so much better. Looking at this 4x over 5x, there's no junk in the trunk. There's no adding and subtracting. So we may cancel out these x's. They cancel out top and bottom, leaving us with 4/5. Now, is there anything we could cancel out with the 4x plus 8 over 6x minus 10? We can't cancel those x's out because plus and minus, there's some junk in the trunk. We can't do that. So are there any numerical factors we could get rid of? Well, if you notice, the 4, the 8, the 6, and the 10 technically all have factors of 2 in them, right? So I could factor out a 2 and get 2 times 2x plus 4, and I could get 2 times, not 6 anymore, 3x minus 5. Now, I can cancel these two because I've pulled them away and out of the junk in the trunk. So they just cancel out. They're gone. Forget they're even there anymore. Now I can focus my attention on what's left over, the 2x plus 4 and the 3x minus 5. So now watch what happens when I cross multiply with it. So I can distribute the 4 and get 12x minus 20. Distribute the 5 and get 10x plus 20. There's no squared term here, so I don't have to worry about factoring of any kind. So I'm going to subtract the 10 over and get 2x. I'm going to add the 20 over and get 40 and divide by 2. And x is 20. I just have the one solution there. I didn't have to worry about the x equals 0. It went away. Where did the x equals 0 go that I no longer see? Right here, when I canceled those x's out. That was basically my x equals 0 solution that I knew wasn't going to work anyway. It's gone. So there's how you can do this example 2 different ways, an easy way and a hard way. The hard way involved no simplifying before cross multiplying. The easier way is to try to simplify this as much as possible. Last point, I didn't really have to factor out the 2 from both of this. If I had just at least factor or cancel the x's out over here and cross multiplied with this, you still get a fairly reasonable, not too bad problem to set up and solve. I get something that looks like this. So I subtract the 20x over and get 4x, I add the 40 over, get 80, divide the 4 over, I still get x equals 20, and it wasn't too terrible. And that's all.